Girls, so I'm going to do one more video now for you, and it's on inverse functions. Okay, now where's my pens? Here we are. So if you want to just write a title. Okay, and these are on page 248. Now, you've probably heard this word before, inverse, and it means in maths, what it means is the inverse of something is kind of, suppose, like the reverse of it. The inverse operation, let's say, of adding is subtracting, and of multiplication is division. So it's flipping it around the other way. So what we're going to do in this, if you're ever asked to find the inverse of a function, you're going to reverse the rule given to you. So I'm just going to write that in underneath. Reverse the rule. And the notation they use for the inverse of a function is f with a little -1. And again, you would have seen that before, the -1, if if we wanted to find an angle and we had the sine, cos, or tan of it, we do shift sine or shift cos or whatever, and that is the inverse basically. Anyway, so so I'm just going to give you a little example here. So let's say I gave you a few couples, okay? So let's say that the function I have here is this. So I have these couples in this function: 1, 4, 3, 7, and 5, 10. Okay? And if we wanted to find the inverse of it, what you're going to do is you're going to switch the coordinates around. So this one will become 4, 1. So the x becomes y, the y becomes x. This one will become 7, 3. This one will become 10, 5. Now, if I was to just sketch that for you, so just graphically, there's something important here. I'm going to show you how you would find the inverse of any given function now. But if I was to just sketch that just here, I might divide this, do my graph bit on the right hand side here. So if I was to sketch that, all I need is positive x-axis and y-axis, sorry. So let's say 1, 4, going up to 10. So let's say 2, 4, 6, 8, 10. I'll just say 2, 4, 6, 8, 10. Okay, I'll just put them in so you have them. Very rough sketch, but it's just for you to see what this is going to look like, an inverse of it. So if we plot them, let's plot f. It would be 1, 4. So let's say 1, 4, 3, 7. So 3, 7, and 5, 10. So 5. Very rough sketch like that. Okay, so you can see that creates a line there, and if I just join that, have an envelope to join it, roughly that line, there's that line there. Okay, that'll continue on then as well, go down that way. So now let's draw, so that's f. Let's draw the inverse. So it'll be 4, 1, which would be roughly there. You can do this out properly with your squares and it'll look a lot better. 7, 3. So 7 and 3 will be roughly there. And maybe actually back a bit, sorry. And 10, 5. 10, 5 is going to be roughly there. And if I just join them, look like this. So there's your line. Now, if I continue this on here, my great ruler I have here, what we will see, and it's maybe not so easy to see now, but I'll just tell you what it is. That when you have, so you've reversed basically your what do you call it, your coordinates. And what happens, and actually be easier for you to actually look in the book as well for this while I'm doing this. So what did I say? 2, 4, 8. 2, 4, 8. Yeah, sorry, 2, 4, 9. They actually have. I think they've used this example. Yeah. So what we should notice, they've done it a bit different. It's a different function. Anyway, when you have a function that's inverse, what happens is it always ends up being, because the coordinates have changed around, the line y equals x. Now remember, the line y equals x, I'll just write it, just a little note, y equals x. It means that if y is 1, x is 1. If y is 2, x is 2. If y is 3, x is 3. Y is equal to x, okay? So the coordinates are going to be the exact same. That on a graph just goes through 0, 0, then 1, 1, then 2, 2, etc. So if I just draw that here, so there's 0, 0, there's 2, 2, there's, let's say, 4, 4, there's 6, 6, there's 8, 8, etc. So that line I'm just going to do in red, like so. And I'll just continue it up here. And that's the line y equals x. And it doesn't look as good as it should, but if you look at the one in the book, you'll see this actually ends up being a reflection, like an axis of reflection of the function and its inverse. Now, my example is not great because I'm using this whiteboard, but that is reflected in that. If you look at page 249, you'll see that better. Actually, if you draw it yourself, you will see that a lot better than my badly drawn sketch. But this will be will act as a mirror line. Okay, so that will be a reflection of that. Now, it doesn't look absolutely perfect on mine, but again, you draw those points and those points, and you should notice y equals x will behave like that. Okay, so that's just something to note in terms of graphs. Okay, what I'll do is I'll just write down that underneath what I've just said there. Thus, f and inverse f create points that are a reflection of each other. In the line y equals x. Okay, so that's the graphical side of things. Because in some of the questions, they're going to actually ask you to draw the inverse. So what you'll do yourself, if you're given a function, you'll draw the line y equals x, and then you'll reflect them. And that's how you do it, okay? Now, how to find an inverse? Let's say I'm not given points. Let's say I'm given a function and I want to find the inverse. Just something to note, by the way. Now, again, I'm going to write this at the top. I'll write it in red, that you can only find an inverse if and only if the function, oh, you can't see that, it says function, is bijective. Okay, so that's just something to note. Just to remind you, bijective means it's surjective and injective. So it's not going to actually work out for any situation where it's not bijective. Okay, again, that can come up. It's a little fact by itself. So I hope you can see that if and only if the function is bijective. Okay, now how to find an inverse. So I'm going to do this on the left hand side. Suppose this is how to find an inverse graphically. How to find the inverse algebraically, I'll call it. I'm scared I'm spelling that wrong. If I am, I'm sorry. Okay, so this over here is graphically. Okay, two ways. So if you write down this function, and this is from page 251, and it's question 3. They gave you fx is equal to 5x plus 3. And they've asked you to find, apologies, find the inverse. So let's say find f minus 1 x. Or they could just say find the inverse of this function. Okay, so how I would do that then, right? The first thing you are going to do is, because you're reversing the procedure of this, so if this is times your input by times your input by 5, and then add 3, you're going to go backwards. You're going to be taking 3 away and dividing it by 5. So you're doing the opposite of it, okay? But for the purpose of this, what we're going to first do is, we're trying to get x in terms of y. Actually, do you know, the first thing to do is write down y instead of the fx. That's the very first thing. Just replace fx with y. And now what we want to do is write x in terms of y. I'm going to write this down so you have it. You don't have to write it down when you're doing some of the questions yourself. Write x in terms of y. What does that mean? Get x by itself. Okay? Write x in terms of y. So let's do that. Let's get x in terms of y. So y is equal to 5x plus 3. We want this by itself. So you would tell me, hopefully to start, you'd have y minus 3 equals 5x. Okay, so the plus 3 becomes a minus 3. And then to get the x by itself, what you're going to do is multiply. So you're going to do y minus 3 over 5. Okay, and that's essentially it. But just notation wise, we want to call this f inverse x. And what we have at the moment is the y over here. So what you're actually going to do is replace that y now with an x. Seems a bit strange to do, I know, but what you're going to be doing is if you were plotting this, you would have the function and you'd have then its inverse. And if you think about it, to make sense of it, yeah, you're switching them around up here, but to actually write the function the other way around, you need to have x. X is going to be the thing that you're, let's say, subbing in most of the time instead of subbing in y. Okay, so that's the answer to that. What I want you to do now is page 251, and I want you to do question 1 to 6, and then question 12. Okay, and let me know if you're having any trouble with them. I think, could be wrong. I think 1 to 6 is going to be the inverse, doing it this way. And then I think 12 is going to be the graphical one. So you get used to that, okay? Okay,